Okay, so for today, you guys are going to be taking notes on multiplying polynomials. So for my West kids, it's going to be Thursday, March 18th, 2021. We're going to multiply polynomials. Of course, if you are my Miller kids, you're going to write Friday, March 19th. I mean, you guys have been doing that the whole year, so I bet you're pretty good at it by now. So I had you watch a video a couple days ago about FOIL, and yeah, it kind of started out weird with that chicken thing. But hopefully you were able to kind of grasp the concept of there's a system, so we stay organized to make sure that we in fact multiply everything that needs to be multiplied together. It's like fancy distribution property. So we're going to go ahead and just jump into examples. Now, what I do need you guys to have is some colored pencils. I'm going to be using blue, red, yellow, and green. If you want to use different colors, that's fine. Just make sure that you coordinate, right, so that where you're coloring is the same as where I'm coloring for each specific color. Okay, so let's kind of do a refresher. If we had just x times the quantity x plus 3, right, old-timey distribution, we would just draw our little arrows, right, or Santa hat, whatever you guys want to call it. X times x is x squared. X times 3 is 3x. And of course it's positive because this is a plus sign. So we're pretty familiar with that. Another example would be if we had like 3x times the quantity negative 2x minus 7. We would multiply 3x times negative 2x, 3x times negative 7. So we would get negative 6x squared minus 21x. Right? So that we're familiar with. That you guys are pretty confident in doing. So now we're going to move on to FOIL method. Okay. You should probably ask your parents, like, do you remember FOIL? And they will either be like, yeah, great, or they might just like run away from you. It either has positive or negative memories. There's really no in between. Okay, so let's just jump into it. We're going to multiply x minus 2 times the quantity x plus 3. Right? So we've got these two quantities we want to distribute, but we want to keep track of what we've distributed. Okay, so we're going to use F-O-I-L. I probably should make this a capital I over here, fancy like. Okay, so the F, if you remember from the video, stands for first. The O stands for outer. The I stands for inner. And the L stands for last. First, outer, inner, last. Okay, I don't know who came up with this. I think it's kind of brilliant, but again, obviously I'm not going to take credit for it. So when we say first, that means I'm going to multiply the first terms in each quantity. So I'm going to multiply x times x, and I'm going to get x squared. I'm going to highlight those blue. The x times x was my first, and so then I also have first highlighted in blue over here. And I know the blue isn't coming through great on the screen, but I promise it's there. Then the outer is the two outer terms. So I'm going to do x times 3. Which of course I'm going to rewrite as 3x because the coefficient always goes in front. So those are going to be my green terms because they're the outer terms. And then inner is the two inner terms, so the ones that are on the inside visually. So I've got negative 2 times x, which of course is going to give me negative 2x. I'm going to make those yellow. And then last is the last terms, right? So visually, again, negative 2 times 3 is going to give me negative 6. And this is where I'm going to use the red. So what I've done is I created a way to keep track of make sure I've actually done all the distributing that needs to take place. Now I just combine these, right? So when I combine them, I have x squared And then I have a 3x and a negative 2x. So when I combine those, I just have a single x, and then I have a negative 6 hanging out by itself. So there you have it. I just multiplied polynomials using the FOIL method. I'm going to pause so you guys can just like take this moment in. This is very exciting transition in your math career. Okay, let's do another example. I won't make you write out first, outer, inner, last again, but I am going to continue to force you to color code. So we're going to have r minus 5 times the quantity 2r minus 1. So I'm going to do first visually, so that's going to be the r times 2r. And I'm going to get 2r squared. I'm going to color code those because you guys know how I like to do that. And then I'm going to do outer, so it's going to be r times negative 1. So I'm going to get negative 1r, or you could just put negative r. It's totally up to you. I'm going to do these green again. Inner, so negative 5 times 2r. So I'm going to get negative 10r. And then last, negative 5 times negative 1 is going to give me a positive 5, right? Because a negative times a negative is a positive. And then I'm going to combine them. So I have positive 2r squared. I have negative 1r and negative 10r, so that's going to give me a combination of negative 11r, and then I have just a positive 5. How are we feeling? Confident? Like we could take on the polynomial worlds? Okay, next page. Let's look at example 5. We've got n plus 2 times n squared plus 3. So just because now we have an extra exponent here, it doesn't change the process, right? So my first is going to be n times n squared, which is going to give me n to the third power, right? Because there's that secret 1 hiding there. 1 plus 2 is 3. Got a color code. And then my outer is n times 3, which is going to give me 3n. And then I've got 2 times n squared. Those are my inners. So I've got 2n squared. And then my last is going to be 2 times 3, which equals 6. So then when I combine, I'm going to get, remember, descending order for the degrees, so I'm going to get n to the third plus 2n squared plus 3n plus 6. I couldn't do anything with these because they don't have the same exponent, right? So I can't really do anything with this 3 and the 2. So they just go in descending degree order, standard form. Everybody's happy. Okay, just when you're getting comfortable, I mean, you know this is coming, right? You knew it wasn't going to stay this easy the whole time. Don't worry, this one isn't terrible. It's just we can't use FOIL anymore when we get to something that looks like this. So what if I have a binomial times a trinomial? Right? So I can't do first, outer, inner, last because I've got this weird term here kind of gumming up the works. Okay? So instead, what I'm going to encourage you to do is really embrace drawing your arrows. So I'm going to multiply x times all 3 terms first. So I've got x times x squared, x times negative 3x, and x times negative 2. And then I'm going to multiply 5 times all 3 terms. Notice that I did the x's up top and the 5's down below just so it doesn't get too cluttered up here. I mean, that's a lot of arrows, right? So I decided to show both processes. So then I've got 5 times x squared, 5 times negative 3x, 5 times negative 2. So I write out all my little mini problems here, and then I'm just going to go down the list and solve them. So this is going to be x to the third, this is going to be negative 3x squared, negative 2x, 5x squared, negative 15x, and negative 10. Right, so when I multiply all those together, I get all these beautiful terms. Now when I combine, I have to put forth slightly more effort because now I have the x squared separated and the x is separated. But I only have one x to the third, then I've got negative 3x squared and 5x squared. So when I combine those, I get a positive 2x squared. Then I've got negative 2x and negative 15x, so that's going to give me a combination of negative 17x. And then I've just got this constant of negative 10 hanging out by itself. So no more of, I can't use the FOIL, but we still have a strategy, right? And that's all that matters. So let's do one more on this page. We've got x plus 4 times the quantity, x squared plus 3x plus 2. So this is where I would advise you to maybe pause the video, work this out by yourself, and then check the work. You guys know I can't pause this while I'm recording. So on our system, go ahead and pause, see what you can do on your own, and then hit play. But I'm going to go ahead and draw my arrows. My x arrows go up at the top. So I've got x times x squared, x times 3x, x times 2, and then I've got these lower arrows, 4 times x squared, 4 times 3x, 4 times 2. Then I'm going to work these out. X to the third, 3x squared, 2x, 4x squared, 12x, and 8. So when I combine all of them, I'm going to lower the screen here so you can see that. I get x to the third, 3x squared and 4x squared is a total of 7x squareds. 2x and 12x gives me 14x, and then I've got my 8 hanging out. Are we feeling good? A couple more? Yeah? Okay, here we go. Last two. So this time we're going to take it and apply it to something that's a little bit more like, I don't want to say abstract because rectangles are not abstract, but not just like straightforward numbers. So let's say we have this beautiful rectangle and I've got a side length of x plus 5 and I've got a side length of 2x minus 9. And I want to find the area. How am I going to do that? Well, we know that the area of a rectangle is length times width, right? So we're just going to multiply x plus 5 times 2x minus 9. Oh my gosh, this is so exciting. I have a binomial and a binomial, so I can use FOIL, right? So I've got 2x times x because that's my first. So I'm going to get 2x squared. I've got x times negative 9. So I've got negative 9x because that's my outer. I've got 5 times 2x, so that gives me 10x. That's my inner. And then I've got 5 times negative 9. So I get negative 45. You guys, I almost forgot to color code these. So I've got my first, my outer, my inner, and my last. So then I would combine those. So the area is going to be 2x squared. Negative 9x plus 10x is going to be positive 1x minus 45. And if it was like inches or what have you, I would have square, like we'll just say units squared because that's how you label area. Okay, so one more example. Okay, it's kind of complex. Don't freak out. It's just like, let's challenge ourselves a little bit. All right, so what if we have something that looks like this? Bear with me. We've got a rectangle with a rectangle inside, right? And we know that this rectangle, one side is x minus 7, the other side is 5. And then we're going to shade in all this around it. I know some of you are like, Mrs. Marsh, you're killing me. It's not that bad. You're going to be fine. And then the bigger rectangle has a side length of x plus 1 and a side length of x plus 1. I guess that's supposed to be a square. Pretend it's a square. Pretend that's the most beautiful square you've ever seen, the bigger one. Okay, so we need to find the area of the shaded region. Okay, so what that means is I need to figure out how to take this chunk out of it, right? Because some of you are like, just find the area of the bigger one. But no, like this isn't shaded, right? So I'm going to let you think about it for a second. How would you do this? What would be your process? Like for real, think about it. Okay, so hopefully you said in your mind, well, if I just need to subtract the areas, right? I need to find the area of the bigger one, subtract the area of the smaller one, which is awesome because we just spent a lot of time doing adding and subtracting polynomials. So you all should be set. So first, let's find the area of the outside square that doesn't look like a square. So I've got x plus 1 times x plus 1. So I'm going to do my first, my outer, my inner, and my last. So I'm going to get x squared, 1x, 1x, 1. I know what you guys want me. You want me to color code, right? First, outer, inner, last. Oh, there's somebody coming in. Hold on. Hi.
You want me to witness my toss locker?
Just a second. I'm making a video.
Oh, you're good.
But I'll be right there. Okay. All right. So we've got our outside square. We're going to combine these. So we've got x squared plus 2x plus 1. Perfect. Now we need to find the area of this little teeny tiny rectangle here. So we're just going to do 5 times the quantity x minus 7. So we get 5x minus 35. Pretty easy, right? So now we have our two areas. Let me draw my little arrows here. Okay. And now I just have to subtract them, right? So I'm going to take x squared plus 2x plus 1, and I'm going to subtract 5x minus 35. Remember, there's that secret 1 hiding here. So really what I have is x squared plus 2x plus 1 plus negative 5x plus 35. So when I do all my amazing mathness, I'm going to get x squared. I have 2x minus 5x, so minus 3x. 1 plus 35 gives me 36. And that would be the area of the shaded region. Ta-da! Okay, so I have been inspired by some of the students to leave what Easter eggs in the videos. So if you made it this far and you email me, so first of all, you got to figure out how to email me. Make sure you spell my last name correctly. And you tell me what kind of dog I'm getting, what kind of puppy I'm getting, which is a mini golden doodle. The next time I see you, I'll give you 2 Jolly Ranchers. Okay, so email me. You have to email me. You can't come up to me in class and be like, "Oh, Mrs. Marsh, mini golden doodle," because that just tells me that your friend told you to tell me that. You actually have to send me an email with the type of dog that I'm getting. Spelling is not necessary, like accurate spelling is not necessary, but you have to email me mini golden doodle. Okay. Have a great day, guys. Bye.